This is TWIS. This Week in Science, episode number 1021, recorded on Wednesday, July 2nd, 2025. Does this show need a science title? Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your heads with fat brains, long lives, and fishy beliefs. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. Just because you didn't hear about it does not mean it did not happen. Just because you don't know about it doesn't mean it does not exist. Fingers in your ears, shouting, la 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 la, does not remove that which you do not want to hear from being said. The sheer volume of things happening we do not know about could fill the world we live in every day with most of what's in it. It would keep going on just fine. The things we do know about are usually the important bits. So the recent effort to remove global warming science reports from government websites, including NASA and the National Oceanic and Atmospheric Administration, will not change reality. It may not even impact public opinion or awareness. What it does show will come as no surprise to anyone that the U.S. government currently has its head completely up its ass. So, what do we do about it? We continue to bring science news. The good news, the bad news, the I didn't even know that was a thing news. Because that's all we can do in this moment on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are here on our weekly adventure into the world of curious people finding out things and then writing about it so that we can learn about it, and then we can talk with you about it, and maybe you'll get curious too. And then more curious people who, oh my gosh, it's a feedback loop. No, anyway, welcome. Thank you for joining us tonight. And as usual, it's, there's stuff going on. There's a lot happening, but, science will continue, I think, in some places.
In some places, yeah.
Yeah, well, like the wave that is science and findings and all that kind of stuff is going to continue with or without, governments. Like science is older than any government anyway.
Yeah.
It's going to keep going. It's not a
Sometimes people were executed for doing science.
And there was like a dark ages where we lost the knowledge. I mean, like for 1,000 years or more.
Yeah.
But their point is, eventually, everything will catch up.
Science persists.
And during the Dark Ages, I think there were people in places currently called the Middle East that actually were having a very revolutionary period of knowledge.
They still had the books.
And that was not a dark age.
They were naming stars.
There was such cool
stuff. They were inventing numbers.
Yeah,
they were doing a lot of work right then.
It's like when, one person stumbles, there's another person to just keep going and leave them behind.
Right.
Yeah. Yeah.
Okay. Hear that, world? It's up to all of you. We dropped the ball.
Yeah. Well, I mean, it's gravity that was kind of responsible for it falling.
I didn't drop it. Gravity dropped it.
Gravity made it be attracted to the surface of the earth. Oh my gosh. Okay.
Somehow.
Yeah, somehow. We have a lot of
Magic.
stories. Yeah. Science is like magic when you don't understand anything about it. So it's like, you want to find out how the magicians do their tricks? Same thing about science. Go figure it out. It's not a trick.
Science is magic plus numbers.
Exactly. And there are a lot of magicians who are very scientific about the way that they develop all their stuff. So it's very cool. All right. On this show, we have a bunch of cool stories. I've got some bad science writing. What else do I have? Stirring.
Hey, you didn't bring any of my stories, did you?
I don't know. The ones that you write? I don't think so.
Okay.
Stirring things in chemistry. And I've also got some brain stories, your fat brain, and some spacey chickadees. What do you have, Justin?
I've got a potential pill for exercising, a supplement to live longer, why cancer has such nerve, and how memories are stored in the brain long term revealed at last. Just kidding.
I can't wait for that one. I love those. I like the brainy memory stories. All right, Blair, what's in the animal corner?
I forget. No, I'm kidding. I have birds, fish, and dolphins. Keep it simple.
I love it. Birds, fish, dolphins, they all kind of, I don't, you just need a land mammal. But I guess the birds land on the land sometimes.
Overrated.
Sometimes
No, actually, I do have a story.
Yeah.
I have a story about land mammals at high altitudes as well. I just didn't mention that one. So I got you covered.
Amazing. Okay. So as we get into the show here, just everyone remember that if you want to find show notes after the fact, they get posted along with recording the podcast recording of the show on our website. For This Week in Science, which is TWIS, TWIS.org. And if you want to subscribe to TWIS for any of the channels we're on, you can watch the live streams on the video channels, YouTube, Facebook, Twitch, and also the podcast is pretty much anywhere that podcasts are found. It's pretty great. But, if you go to twist.org, you'll find all the things, including our Patreon and Zazzle links. And those are the ways that our show is supported by listeners like you instead of corrupt business entities. So help us keep going. You ready? Should we have the science?
Mm-hmm.
Yeah. Okay. I want to start the show badly with a story about how large language model use in science is impacting publications currently and what's going on there. A study just published in Science Advances is called Delving into LLM-assisted Writing in Biomedical Publications Through Excess Vocabulary. Yes. So the researchers wanted to find out how much over the last year or so, or, a few years, these large language model algorithm tools are being used by scientists in their writing process for the papers that are being published and that are being shared, that are indexed by PubMed and other places. So the researchers did a large scale approach. They looked at vocabulary changes in over 15 million biomedical abstracts from 2010 to 2024. So you've got years of control with really, maybe more of like the word processing Grammarly kind of help, right? Google or others, suggesting a slight, this word change or, anyway, to 2024, 2 years since these LLMs have become very prevalent. Okay. They led to a very abrupt increase in the frequency of certain style words. At least 13.
However,
Therefore,
M dash, but not, that's actually not true. You should listen to Mignon Fogarty's Grammar Girl, and she debunks the whole.
It's something that it's something I've noticed actually just reading studies is the word however. It's like all of a sudden everything is however. Like I don't think however was being used very much before the LLMs came along. And now almost every abstract I see has however.
But so, however, how do you differentiate that somebody's using an LLM versus just a change in the public vernacular over 15 years?
Yes. So do the frequency changes happen normally? Are there changes regularly within language? Of course there are. And so that's why they wanted to, make sure that they took this very, very large set of articles from PubMed to look at the abstracts to quantify what was going on. What they have found is that there was a huge change when ChatGPT was released, and what happened after is it's like a cliff of what happened. So until the end of 2024, the 15.1 million English language abstracts from 2010 onward, they got rid of contaminating strings and things that were, that didn't quite make sense and that were contextually confusing. And they computed a matrix, and this is from their results section, of word occurrences showing which abstracts contain which words. They got a binary matrix. For each word and year, they found the number of abstracts in that year that the word appeared in and obtained its occurrent frequency. So they normalized over all the papers in each year. And then they ended up focusing on over 26,000 words with a very, very, with a p value greater than 10 to the negative 4 in 2003 and 2023 and 24. So this corresponds to over 100 usages by words, a certain word per year. Okay, so some words increased their frequency.
And don't tell me, I'm going to guess they're all transitional phrases.
Okay, so I'm going to try and open the figure
However,
viewer.
despite, therefore, furthermore,
I'm gonna try
all of those absolutely useless filler words.
Yeah. Okay, so I'm going to present these words to you and you're going to go, "Oh my goodness. It's so true." So, we have the frequency of delves. In 2023, suddenly it shot up in its frequency and how it was used.
Well, pandemic, you can't fault on anything other than there being a global pandemic, but that makes sense.
And they did take the pandemic and publications and what was happening during that period of time into account during those years. And so that is actually part of the way that they looked at the data and looked at some of the words. The word crucial increased around 2020. Potential increased significantly at the 2003-4 year rate. Important took a nosedive.
Because it was replaced by significant, crucial, and potential.
Yes, exactly.
Mm-hmm.
That's it. And so as a control for like what other words were changing relevant to societal stuff, pandemic took a huge spike 2020, right? Ebola took a huge spike around 2015. Convolutional.
Yes, that one's wild.
That's a weird... Yeah, that's a weird word.
Is that even a word?
Yeah. These.
The these one is weird to me because it goes down, 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 and then shoots up again.
At the beginning of the LLM use.
So that makes sense. And if they look deeper, they would also probably like these, those, it's what do you call it? A summary form versus a narrative, or it's writing that is summarizing it for the person who is preparing the information versus how you would prepare reading for an audience. And so that's part of what it tends to do, is give the user a summary of information. So it's right, it's telling you back like your list of information that you've put into it, as opposed to trying to describe something for a reader. It has a hard time doing that for describing something for a third party. But
Absolutely.
summarizing your notes is what it's probably much better at. So these make sense. You know, these things that these lists, and significant versus important, I think that's actually a pretty good one to have changed.
But here we're gonna move into the assisted writing through excess vocabulary and the frequency ranges, the frequency ratios of words between 2024 and 2022. And you have words, and these are and based against, so x-axis frequency in 2024, and then the frequency in the years from 2022 to 2024. And what we find is that delves, underscores, delved, excels, garnered, aligning, pivotal. But there is a significant is significantly less in its frequency, which I think is very interesting. And then
I think significant is a like a better word than the comparable important. Like crucial is a little, sounds like overstatement. Significant means that like it was there enough that it's part of this story, that we're part of our observation. Important puts a weight on it, and that's tough to do when you're just relating what was there. You know what I mean? Suggesting that something is important or crucial. Those ones are tough. But it's significantly part of this story. That makes sense to me.
But it's interesting that these words that there are some words specifically coming from these large language models, and it's changing
highlights,
the way
underscores.
And so there's another different view on the analysis, which is instead of the frequency ratio, it's the frequency gap between. And so we have words that like potential and significant, this, there, through. So words that we might actually use more often or used less by the LLM. And then we have other information, nouns, verbs, adjectives. There's a huge increase in 2024 of verbs in scientific publications. There's also huge increase in style words like delves. So the words that are being used more and more often are changing in their frequency within the writing. So there's something going on there, and whatever the final interpretation of all of this data is that the more we use this writing and then put it back into the data that is being the training data, it's going to reinforce the same trends. And we're going to see, if it continues, we will see a significant shift.
What kind of shift?
Significant shift in the words that people use. So there's also, we're seeing common words and the rare words being used more often. There's a particular analysis of the frequency of abstracts containing at least one word from a given word group. The frequency gap estimates for various fields identified based on journal names. We also have the frequency gap estimates for various countries and for different journals. So it's interesting that they're breaking it down into kind of what's getting published where and how, and what the different, what the comparisons are. And it seems to be very similar in English speaking and other other languages. So the results parallel each other. It's not just happening in English language publications. It's happening in all places. And the bottom line here is that they have determined that these LLMs are impacting scientific writing, and the effect is actually greater than the effect on language that the COVID pandemic had, or concern about Ebola. Yeah. And
some
and
of it
so,
doesn't...
so the thing, at least the data that at least 13.5% of 2024 abstracts were processed with large language models, according to their analysis.
Yeah, and then some of it just isn't that bad. One thing I also have noticed is that you might have the word potential. It's taken it skyrocketed, right? Everything is potentially something. But in that, I've also noticed I don't read papers that say this can open the door to the pathway to leading to, they got rid of sentences of caveats and just say, now they just throw potentially, could be, might. But it used to be there would be like this run-on phraseology of, this could lead to the pathway of a door that would let us through a window in the back alley of potential, but someday, and it would be this totally endless caveat.
Right, but I think what's happening is maybe they are teaching more scientists how to write now, which is, I think, really beneficial.
Maybe. I think I've noticed, Grammarly will, because I need something to keep me from messing up the English language. Will suggest rephrases, and so I can see how these things, if it's recommending the same rephrasing, or ChatGPT is offering the same rephrasing of things, you're going to see these common trends. But if it's getting rid of the trope language, if it's getting rid of the, this is a meaningless phrase that everyone has been throwing into their scientific articles for 100 years, and it just needs to stop because it's bad grammar, or it's just meaningless, adds no value.
I love it.
Then it might be becoming more concise.
Yeah, there's so many science journalists that have lists of phrases and terms that they're like, please stop using these.
Yeah. So it might just be making things more concise, which would be not a bad thing.
Yeah, but I'm not saying that these algorithms, these tools, can't help people write more clearly and tell their science stories in better ways, in more effective ways, so that people can understand them. But at the same time, relying on them as opposed to, using them, it shouldn't be a crutch. It should be, something that accents it, something that,
13% doesn't sound too bad.
Once upon a time, we didn't have encyclopedias, and you had to figure out, I don't know about Norway. How am I going to learn about Norway? And then oh my gosh, somebody sold my family a bunch of encyclopedias. You could go to the encyclopedia and learn about Norway. And then came Google and search engines, and Alta, what was it? Was it Alta? Whatever it was, Lycos. All these things early on, search engines. You could start
Excite, the greatest search engine that there ever was.
There were the BB chat rooms, the places where you could talk to people and ask questions. And so you could we started being able to crowdsource for information and learn stuff from more people. And it's not that any of this is bad, but when we allow it to replace our thinking and our process of even like it's like you become a better teacher or you learn a subject better by teaching it.
Mm.
The minute you have to start explaining something to people, you realize where you don't understand things. And so teaching is the best teacher.
Okay, but now I lost what you're talking
Anyway,
about.
So you need to tell a story about us needing to exercise.
Okay.
And,
Wait, hang on, you left this in the... Okay, all right.
I didn't leave you any... I left you hanging like Tom Cruise off of a mountain that if you're not exercising like him, you might just fall. So...
Oh, is it the exercise story? Okay, so... These are quick stories.
I know, I tried.
So this is Capital Medical University collaboration with Chinese Academy of Sciences reports that betaine, molecule produced in the kidney, enhanced through sustained exercise, operates as an inhibitor of a downstream thing that then inhibits or would have caused inflammatory age-related pathways. So basically what they did was they narrowed down the metabolites and things taking place during exercise. They picked this one molecule and they did an experiment where they basically gave it supplemented to some mice, and they also had some humans in this trial as well, 13 humans. Basically, they managed to isolate that this one molecule, this one protein, was able to mimic the effects of exercise, even without exercising. Aged mice receiving the betaine supplementation exhibited multiple improvements: decreased tissue fibrosis, fewer senescence markers in organs, increased muscle strength, and reduced depression-like behaviors. So,
this sounds great.
Yeah, so this is like, okay, exercise mimicking supplement, attractive to many, but it actually could be used in an urgent therapeutic scenario for to give some of the benefits of exercise, down-regulating inflammation and the like, to people who are unable to engage in any physical activity.
Yeah, so people who are, disabled, people who are ill for a period of time, people if you're bedbound, maybe also the other impacts of leading to the benefits in mental health, which is not necessary. The impacts of exercise on mental health cannot be understated. And so maybe this is something that could help people that's not an SSRI, right? Something that could help people with depression and other mental health issues.
Yeah, they also got to drill down. Like, this was also mostly on mice. They had some human subjects involved in this, but they need to do this on a larger human cohort to test for safety and all the rest of it, to see if you can extrapolate the small study to a big world result. Yeah, like one of the things that is wild is that if it's unlocking if it's allowing the clearing of senescent cells by this one supplement without exercise, that is the thing that when you get these cells that they get tired, they get old, their mitochondria is like, I'm pretty much done, but they're still there, and they start sending out weird signaling to their neighbors and start disrupting the tissues in whatever organ they're in. And that's an age-related malady. And what happens in elder scenarios is exercise is a lot less. And so those things that mitigate senescent cells stops happening. If you have a supplement that can clear senescent cells to some extent, my goodness, you could have a longevity boosting effect as well. Yeah.
You can end up having a situation where potentially You are improving the way that the whole system of circulation works, the lymph transfer, the mitochondrial function in the brain, like all of that stuff, so that brain health and the garbage disposal that often starts to go awry. And all, like you said, like the slowing of movement and the stiffness that occurs as you get old. You don't move as much, and so things start to break down. And if oh my goodness. It's not about it could be longevity, but it could also be it could be maybe extending life slightly, but maybe extending healthy life longer, so that the senescent period, the period in which you're declining, is much shorter. So in terms of quality of life, you live better longer.
Better quality of life.
Yeah.
Yeah.
Yeah. That's awesome. I want some.
Well, let's
How do we get it?
So I'm gonna jump to my
Do
next
I
story
eat
real
broccoli?
quick, because it'll
What's
only just because we touched on the longevity aspect of this. Before you jump in, this is a totally different study. Obese mice live 26% longer with a single protein overexpression. What's amazing about this is that they've tested this. This is fibroblast growth factor 21, FGF21, and they've been interested in this for a long time because of the way it modulates metabolism across many tissues in mammals. And an early investigation found improved insulin sensitivity, lower fat accumulation in the liver, and some of the pathways that we know are tied to longevity. However, it also resulted in dwarfism. So this was transgenic mice. So before you jump in and be like, I'm going to try the next new thing, hey, wait, let's test it. Let's test it. I don't know what a dwarf mouse looks like, and I may be a bad person for wanting to see that.
They would be smaller.
They're just tiny. Yeah.
Okay.
They're smaller.
So in the first round of the experiments that they had done previously by a different study than what we're talking about here, they were transgenic mice that were expressing FGF21 from birth. And there was a lot of developmental issues that took place, including dwarfism, where they just didn't grow as big, even though they showed some of the other positive effects that they were kind of trying to suss from having this overexpressed. So in this study, they did something kind of interesting. They have transgenic mice again, but this time the expression of FGF21 is only going to occur in fat cells. And it's got a trigger where they have to feed it a molecule. In this case, it's doxycycline.
Doxycycline
Into their food.
That's an antibiotic.
It's an antibiotic, but for whatever
reason,
reason, molecularly, it can trigger the release of the FGF21 in the fat cells.
And it's dose dependent. There's some interesting work that I don't really understand, but there's the antibiotic threshold where it gets rid of bacteria. Kind of. It's old now, so not so well. But then there's like the what they call the non-therapeutic level, because it's doxycycline is supposed to just be for antibiotic use, but the non-therapeutic level, which is like for humans, I think like 50 milligrams per day or less. It has other impacts, like it does other things that do not impact bacteria, but impact aspects of like cellular physiology. So this is fascinating.
So they used it as their key to unlock the mechanism in the genes. So they allowed the mice to get past the initial development stages, right? So the genes are in there to overexpress FGF21, but they're not turned on until they get the antibiotic supplement. So they get past that developmental and dwarfism risk and let the mice get a little older, and they're also overfeeding the mice, and they're doing some other things to make it a challenge. And then they start the overexpression. And so in that group of mice, of course, there were no developmental issues because they're already full grown. Yay! And
That's great.
the median survival versus control was 2.2 years versus 1.8 years in the controls, which is about 26% increased longevity in the FGF21. Several of them, it says, lived as long as 3.3 years, which is like almost twice the lifespan of the average control. I don't know what the maximum on the control was, so it's not quite like they doubled, but twice what some of them lasted twice what the control median was. So pretty cool. Didn't seem to have any downside effects. They went to, they took them to sliced up with the pathologists and looking for problems.
Yeah.
Yeah, it didn't really seem to be an issue.
But in terms of something not just for longevity, but for situations of metabolic disease, which lead to, diabetes, or if someone, depending on type 1, type 2 diabetes or other metabolic, disorders, something like this could really be beneficial. Once more, living longer, better.
No, and you start combining them,
Right?
all the longevity things all at once. And it turns out they cut your life in half. Wait till they've done the study, people. Again, I got to tell you, you got to wait until they've tested it. Don't do things without validation, testing, confirmation, replication, all that stuff.
Yeah, no, especially now that healthcare is going to be less. You don't want to do that.
No, healthcare is going to be more. It's just going to be compound quackery. That's the scary thing. People still need healthcare, and you're going to see deregulation of woo-woo healthcare, and it's going to be a nightmare wave that's coming.
I mean, I've had those nightmares. Blair! I don't want to talk about nightmares anymore, but I mean, I think I don't know. Do you want to talk? You're going to talk about predators right now?
Yeah.
Like feeding.
So
you're not scared, are you?
No, get this. What if you saved an endangered bird from predators by feeding the predator? What?
Yeah.
This is from Scotland's.
Isn't that what dogs and cats are?
What do you mean?
Aren't they fed predators? The predators
Yes.
that we feed?
Yeah.
But as we've discussed many times on this show, you feed cats and they still kill things, right? So that's why feeding a predator.
They're evil. They're just evil. Psychopaths.
Anyway, this is looking at Scotland's capercaillie population, also known as a wood grouse. And there is around 500 of them left in the wild. So they are very endangered, in danger of extinction.
Significantly, yeah.
One of the main contributors to that is that pine martens, my old friend the marten, are often eating the eggs and chicks when these guys are brooding. So they've been trying diversionary feeding. And that's a conservation technique where you reduce predator impacts on vulnerable species without harming the predators themselves. The pine marten is a local species. And they do that by providing an alternative easy meal. In this case, it was deer carrion provided by another wildlife conservation effort where they were actually doing a deer cull. So this is recycled meat.
I love
So
that. Like the collaboration between the synchronization. That's amazing.
Yeah, and so they laid out the carrion. It gave the predators a readily accessible food source, and therefore they didn't need to search for eggs or try to eat eggs or baby capercaillies. even though they might be right next door. This was a partnership between University of Aberdeen, University of St Andrews, Forestry and Land Scotland, RSBP Scotland, Nature Scot, and Wildland Limited, for all of them working under the umbrella of the Cairngorms Connect Predator Project. They used camera traps to monitor the Capercaillie broods. They were able to find out where there was eggs and eventually chicks, and then they were able to provide this diversionary feeding. They found that in areas where alternative food was available, 85% of Capercaillie hens had chicks, compared to just 37% in unfed sites. It's a pretty big difference, and so that raised the per chick rate to 0.82 chicks per hen, from 0.82 chicks per hen to 1.9. So they increased productivity by 130%. Why does this matter? Well, in particular, it's important because in some of these cases, they actually prevented what's called catastrophic brood failure. So there were individuals who had no genes moving on to the next generation because a pine marten ate all of their eggs or chicks. If you can prevent the catastrophic brood failure, then those genes continue. There's less of a genetic bottleneck, particularly when you get to lower numbers. And so preventing that catastrophic brood failure is really in some ways the most important part. I don't care how many chicks you have, as long as you have at least one. And they also, yes.
Is there going to be any ramification from feeding wild martens?
Don't they say don't feed wild animals?
This is exactly what I was going to mention next, is that they're not feeding these guys year round. They are really only offering the carrion during a focused 8-week window, which is when the capercaillies were nesting and chicks were hatching. So really, they were only doing it for 8 weeks of the year to make sure that at this very important pivotal moment, when the mothers are sitting on their eggs, they can't move, and the babies are either in the egg or they're brand fresh hatched. This is the short-term period that allows for increased populations, but does not create a pattern enough that the pine martens will stop feeding themselves.
So first of all, that image that was up there,
Oh, I'll bring it back. Hold on.
I almost don't believe it.
The male is so beautiful. It's
No,
like
Grouses
it
are
looks
wild.
like if you were like, what culture on planet Earth is this bird attempting to represent? You could only come up with Scottish. It's got like this little Scottish beard. It's got the Scottish colors. It's like, oh, did the Scottish people try to emulate their culture after this bird? It's just too spot on.
Peacock, but make it Scottish, is what this is.
It's a Scottish
turkey.
peacock
A
turkey.
Scottish turkey.
Yeah.
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 Absolutely.
It's hilarious.
They're big, too. They're like 9 pounds, which for a bird is huge. They're like 30 inches. They're enormous.
So these pine martens, what happens when now that they have a taste for deer meat? Are the deer in jeopardy? Are they going to start hunting them?
You know, if they did, that would probably be a good thing, considering there is a deer cull happening in Scotland. But they won't. Martens are small. They're not going to
you get enough of them. Hey.
No. They're not going to swarm them like World War Z. No, they're too tiny. They're mostly scavengers. There's a reason they go for eggs and chicks. It's not really hunting. It's just finding, right?
But if you okay, so here's the concern: how do they learn to go after eggs? Is it a taught thing? Is it an instinct thing? How long can you feed them as this easy scavenge meat before there's a generation that unlearns egg hunting? Which I guess is good because it's the thing you're trying to untrain them for, in a sense, or keep them from doing. But on the other hand, now they have to go out there and survive without the provided food, and what happens? It's so dangerous. It's so dangerous.
It's tough. It's tough because, yes,
everything.
you're not supposed to feed wild animals. Are you
I know how
going
you
to
feel about martins,
kind of,
so you're probably
yeah.
like, oh, something bad happens to martins that they brought it on themselves. And I think I think I like that bird, but just fine. So maybe it's for the best. But still.
Yeah, I think they're really banking on the 8 weeks, to be the situation. The fact that they're only doing it in this very particular 8-week window. They're really hoping that this is not going to shape future behavior beyond that. There are eggs before that, there are eggs after that. There are eggs that never hatch, that have no babies in them. And the pine martins can eat those for sure. So there's a lot of opportunity still for them to try. There's also other birds with other eggs.
Oh, yeah.
So
I'm looking where I'm sharing the document that is involved in this plan that they've come up with, and it's very complete.
A bird with a beard.
Yeah. Yeah, but they're going to be tracking changes in the pine marten populations as well. They're going to be tracking other prey species like voles. They're going to be looking at other bird species. They're really going to be taking a close look at like the ecosystem and the animals that make it up and how they interact, which is the web. Which is
I would say the ecosystem's probably pretty disrupted already, but so that's kind of part of the issue too, is if these birds are already down to less than 500, they're basically not fulfilling their function in the ecosystem currently. And so
like being the Scottish mascot.
Yeah. If you throw the pine marten into kind of upheaval, who's to say that's a bad thing if the current prey item is functionally extinct?
Yeah. It sounds as though also in this plan, they've got, they're going to be removing fences. They're going to be reducing disturbances that are human caused as well, like mountain biking activity. They're going to try and deal with people walking their dogs. They're going to be dealing with farming. They're going to be really trying to look at land management within the area. Like the whole thing is a really interesting, complete plan, and I'm excited to see.
I just want to counterpoint one thing you said, Blair, which is I get it if they're doing a diversion for a bird that's going to go extinct, and so they might be without it if they do nothing. Fair enough. On the other hand, that would also probably be maybe a smaller population of martins as that resource dwindles versus feeding them all deer meat and having maybe a larger population that is then also still maybe faced with losing a resource.
So I think you are thinking that the marten only eats eggs.
No, I'm not thinking that.
They eat mice. They eat rats. They don't hunt deer. They eat mice. They eat rats. They eat pests. They eat other carrion. Yeah, absolutely. And so it's actually really important to keep the pine marten. You know what else they eat? Snakes. So
there's snakes in Scotland?
Of course, there's snakes everywhere. So they are a part of the food web. When you remove a predator, even a mesopredator, a predator that is hunted by other predators, you are still going to have an impact if you remove them. There's going to be a cascade, right? So they have a much larger function beyond just eating eggs.
I'm not saying get rid of the martins. I'm just saying if you feed them and you end up with more of them and then you still don't save the birds, well, you might be... Now you're...
This is where I think it's getting very interesting in that they're going to be doing a whole bunch of stuff at the same time because the environment has been disrupted enough that these birds have become easier prey for the martins. Yeah. And so the martins are more easily able to take them out because their nesting sites or whatever they do. The martins are like, "Ooh, I know where you are and you're easy to get. I'm going to eat your eggs." And there's nothing really to help the caperwalis. At least,
one thing that might,
but like with the deer and other, in America, we've had issues with deer and vegetation, and when the vegetation becomes too low, the deer die off, and then the vegetation comes. There's like these boom and bust cycles, and what's happened is the disrupted environment is what the martens probably have a bit of a boom right now because they're able to access food supplies that maybe once upon a time they were not able to because of the disruption. So you start removing the disruption, you go over here, you distract the martens and other things, and then hopefully things will get back to normal, but you pay attention to see how does this affect the population of the martens, and you do it scientifically with monitoring the whole time. It's not just like, let's feed them deer.
And I'm being informed that it is Ireland that doesn't have snakes.
Exactly.
And the reason they don't is because they sent them all to Scotland.
It's true.
And a couple to Australia.
Yeah. I love that. I honestly, the amount of thought and the depth of planning for this, Blair, I think it's really impressive. It's pretty cool.
It's neat. It's definitely a different kind of perspective.
Yeah.
Well, since we're talking about feeding animals, real quick, I can also tell you about orcas and their pet humans.
Yes, please.
Humans?
Yeah. So, come on, computer, stay with me. Okay.
We make great pets.
Humans do? Yeah, I think so.
We make great pets.
Researchers
I remember,
from Canada.
that's a song. She's not just babbling.
Yes, I remember that song.
Okay.
No, I know that song. Researchers from Canada, New Zealand, and Mexico, they reported on 34 interactions spanning 2 decades in which orcas in the wild attempted to offer food to humans. The incidents took place in oceans around the world, from California to New Zealand and from Norway to Patagonia. So in a lot of different areas, this was not one social organized group that kind of had this social spread of information. Orcas are doing it everywhere. They often share food with each other. And so the assumption is that this is a similar activity when they attempt to share food with humans. The 34 incidents of food sharing, on 11 of those occasions, people were in the water. In 21, they were on boats. And in 2 cases, they were actually on the shore. And the orcas were reported to have attempted to share food with them. Some were captured on video and in photos. Others were described in interviews. Ultimately, they indicate that offering items to humans could include a situation of a learned cultural behavior, that they're teaching each other to do this. It could be exploration. It could be play. It could be an opportunity to learn about relationships with humans as opposed to relationships with orcas. There's a lot of conversation in the article and in this press release about how we feed our dogs and cats, and how those animals might potentially, if they had more brains on them, try to share food with us. But as far as they can tell, this is the first non-domestic animal sharing food with a human.
Well, that's still some interpretation, though. I mean,
yes. Yes.
I can
that's
picture a couple.
That's the piece.
I can picture a couple orca talking, being like, "Hey, what'd you do this weekend? Oh, I went humaning. Any bites? Nah."
Yes. So that's exactly what I thought of. First of all, are we their pet? Like, we feed dogs and cats. Are they feeding humans because they find us entertaining or interesting or comforting, right? So are we the orca's pets, is my first thought. My second thought is, yes, is this an attempt to catch us?
Bait.
Yes, is this bait? Absolutely. Or is this something else entirely? Is them just playing around? Watch. I'm gonna offer him a dead fish. You watch this. It's gonna be hilarious, right? They play with dead fish on their head. We just talked about this last week. Orcas do weird things.
Or like when people feed birds at the park or something, so that more of them come around so they can watch them longer.
Mm-hmm.
Maybe they're like, "Oh, those humans are so curious, but they always are going somewhere in such a hurry. Here, why don't we throw them a dead fish? Maybe they'll stay there and eat it, and we can stare at it for a while, figure it out."
Yeah, they're doing their own science experiments. I love it.
I think that's all too possible.
Yeah. Anyway, so we don't know why they're doing this a lot. 34 instances.
Around the
Researchers
world.
are going to keep an eye out. But they're doing it for some reason, and it's maintaining across cultures and across the whole world for some reason.
Maybe they think that we're hungry because we're so small.
Mm-hmm.
Look, their boat is as big as me, but there's so many of them on it. They must be hungry.
Or they're hungry and they want to eat us.
Bait. That's right.
I'm telling you, it's about going humaning. It's not whether or not you catch anything.
Yeah.
It's
They're having a nice heart to heart while they're trying to catch a human.
Mm-hmm. Yeah.
Oh my goodness. I don't know. Maybe the salmon hats on the head were
for floating beer cans around the same spot, just in case.
I mean, if the orcas were smart, they'd actually like start, bringing booze to the boaters. But how do you get on their good side? I don't know. What? But orcas are so cool. There was another study published in Pure J, I think this last week, that was researchers were using large language models to algorithms to try and actually talk to orcas. So to adapt and actually it's from 2023. Never mind. I don't know what I was talking about, but yeah. Anyway, we still don't know how to talk to orcas, and they probably know how to talk to us better.
Yeah, they're dolphins. They're really good at that. Yeah,
they are good. Yeah. My one last story for this particular section of the show has nothing to do with dolphins. It is chemistry, and everybody who has been a science undergraduate has had chemistry lab and had those situations where people at the lab bench next to you are doing the same exact thing that you're doing, and there's that point when you put like the stir bars in, and like there's a magnet on this little device.
I love those.
And you turn it up, and the stir bar is this little piece of magnetic metal that spins around and stirs your solution. And for whatever reason, the people at the lab bench next to you, their stuff works great, and yours doesn't. And you're like, I did everything right. I don't know what was going on. What happened there? A paper just came out reporting that maybe if everybody put their magnetic stirrers exactly the same in the containers, the flasks, the vessels, for the mixing, maybe then we'd all get the same results. The researchers looked at all types of reactions using magnetic stirrers from different manufacturers. They used cameras to record variations in color, nuclear magnetic resonance spectroscopy, electron microscopy to look at chemical changes. One thing they looked at was palladium particles being formed in solution. And it's just such a fascinating result, is that they discovered that where and how you place your stir bar can impact your results. And so the difficulty with reproducibility of some chemistry experiments they may just be the result of not putting your stir bar in the right place. I'm going to see if I can share this video with y'all for a second.
This kind of makes sense and it kind of doesn't. Like, liquid solutions, I feel like, are supposed to be able to diffuse.
And yes, that there should be this liquid fluid movement of molecules that shouldn't be impacted with how they're stirred. But what their results showed was that the more stable the stirring positions are on the plate, the better the results. So in results that are being published by chemists who are writing papers, like what they saw was a conversion difference about 10 to 20%, and sometimes even more, based on just the placement of where the stirrer was. They saw the same reaction mixture have very, very different results, and that can change the way you can reproduce or even, just get things done in your lab. And they're, because of this, recommending that in the methods section of papers that are being published, that researchers should really be uh, describing the stirring positions on the plate, doing a control run with a single vial in a particular location, reporting the type of stir bar, and the type and the size of the reaction vessel in the experimental section. So, like, instead of just being like, we mixed the solution for 30 seconds, it has to be, we mixed it with this brand, this thing, this way, and this, to get rid of the potential confounds. But it's so fascinating that there are these little tiny discrepancies that you wouldn't even think about for the reasons that you said. And such a simple variable.
Yeah, it's so my experience in high school and college labs, I thought that was standard practice. I guess maybe they make you do that in the classroom and then they don't make you do that when you become a grad student. I don't know.
Like describing everything.
Yeah.
Yeah. Yeah.
Because that's, I don't know, have you ever seen the whole video where you ask kids to tell somebody how to make a PB&J? Have you seen this?
In high school, we did this where you had to, like, you explain it to somebody who you weren't looking at, and they had to do it. Haven't seen that video, but we actually did this. I did this in high school,
Yeah.
and the messes that were made were so ridiculous.
Well, that sounds even worse because you're not watching. But this one, the kids were watching. They were in like 4th or 5th grade. And they were like, put the knife in the peanut butter. And she like tried to get the knife in the peanut butter and the lid was closed. And then they said, okay, now spread the peanut butter. And she took the peanut butter and she spread it on top of her hand. Right? And they said, no, on the bread. And she goes, okay. So she spread the peanut butter on the outside of the bread bag because they didn't tell her to take bread out of the bread bag.
That's exactly.
Yes. Yep. It's just, this is that. I will say though, that my high school and college labs had the magnetic stands for the Erlenmeyer flasks.
Yes.
That pulled the stir magnet to the center of the flask.
Right. I mean, that's where the main magnet is. But if you have different size stir bars or different different spinner base, like, I think it's a very interesting point, and just the dynamics of the fluid, like how the physics and the forces change and the chemistry changes as a result of that, these are factors you need to take into account. Like, it's so interesting. Report your stir bars, people. It's very important.
Well, and that's one thing that I've honestly never seen calibrated in a lab is the stir. I've never seen
how many
a
revolutions is it? Yeah, absolutely.
Every scale, every measurement device gets periodic calibration to make sure that it's doing exactly what it's supposed to be doing. But you put the stir bar in there at 450, you assume that's how many revolutions it's doing. And if it's doing more and it's doing less because this thing is a 10-year-old piece of equipment, nobody's checking.
You should have there should be some kind of like a laser calibrating instrument so that you bounce it off to be able to see. There are
for all sorts of other things that do RPMs, like stirs on
because the assumption is
there's a little laser
stirred is stirred
tag on there that will tell you the RPMs.
Yeah.
But in the stir, there isn't a thing that is. You would have to put some sort of tracking device within the stir itself,
Good, but
that might be a solution.
I don't know. I'm
Listen.
thinking of like, the police radar gun, but for like
Yeah, but you're
for a
in the
stir bar.
solution. Like if that's the problem. You're already in all this other stuff that's in the way. So it would have to be embedded in the stir bar itself,
or within
tag.
the device that is the stirrer.
Now, if it's a agitator, agitators have all sorts of ways to verify RPMs. That's like the laser thing that you're talking about. Exactly, perfect way to do it.
I'm an agitator. Are you an agitator? No, we're not agitators. We're just people who like science. If you're enjoying the show, thank you for being here. Also, please share it with your friends because, we're here to talk about all these wonderful, weird little discoveries and big discoveries, the questions that drive us through this world. We might never answer some of them, but hey, we're trying. We're developing technologies. We're answering one little question that leads to something later that potentially gets us to answering a bigger question down the road. And that's that science. It's a knowledge generator that leads us to progress and hopefully to wisdom through time. Share TWIS with your friends. Also, if you are able at this point in time, head over to twis.org, click on the Patreon link. We would love to have you as a supporter of this show. Our show is listener supported. We are not supported by corporate interests. We are not supported by venture capital. We are not supported by big money, dark money, anything like that. It's just you helping us keep this show going. And it would be amazing to be able to read your name at the end of the show. I would love to say thank you. Please be a part of supporting this show. We really can't do it without you. Also, there's a Zazzle link, and there's really cool stuff that is our TWIS merch and everything. There are cool things that Blair's made. Blair's Animal Corner. Oh, wait. It's time to come back to the show right now because...
With Blair. Wait. Now you guys see you got me all ready
I got you riled up. Oh, dude. It is time for that point in the show we call Blair's Animal Corner.
With Blair.
Loves are creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
It's time for you to go back to school.
Uh-oh.
No.
Just kidding. It's time for ichthyologists to go back to school.
Yeah.
Fish school. Does that... Never mind.
Swim with the fishes?
Yes. It's time for ichthyologists to swim with the fishes. Anyway, since the 70s, conventional wisdom has been that fish swim in a flat diamond. When they make these big schools, it's a flat diamond formation. But recently, a team of researchers from Princeton and Harvard ran an experiment to check that assumption, and they found conventional wisdom was wrong. They swim in a dynamic pattern the researchers have coined a ladder, where they're staggered in 3 dimensions like an echelon of fighter jets. This was discovered by a professor of robotics at Princeton who adapted computer vision software, which was originally developed to track individual animal movements, and they used that to collect 3D data on fish school formation. They worked with Harvard University biologists to analyze the group of 6 giant danios swimming for 10 hours in a tank with recirculating flow. And they found that the fish almost never formed a diamond and instead swimmed in a ladder shape of 75% of the time. Why did we think it was a diamond?
Wham.
What did I say?
I never
Swimmed.
thought it was a diamond.
Swimmed?
Did you?
Did I say
Yeah.
swimmed?
Nobody
You said
swims.
swim. I'm not trying to bring the whole show to a halt between swimmed and swam. I think they're both appropriate.
Oh, it's such a swim swam.
I should have said
Okay.
nothing.
flew through a liquid medium. How about that? The diamond formation. Why? Why do we think fish swim in a diamond formation? That was reinforced by models and experiments since the 1970s, but they were all in 2D.
What?
Why? Why?
Because that's what we had. But what's amazing, and I'm from the 70s, the whole world was 2D.
Yes, but it's been 50 years, people.
That's the interesting thing about assumptions. Like, you have to go back and challenge that stuff. And I'm so glad that they did. But how many papers have been based on the diamond?
Yes. Generally, the research was limited to a flat plane because it's difficult to capture accurate 3D movement from multiple camera angles. Which I don't buy. I feel like you can do that now. You've been able to do that for many, many years at this point. But
it's
regardless.
Look, the dangerous thing that with assumptions is that there are things that have, and sometimes it's just little stuff that seemingly goes unnoticed that's just taught in school, and then you've learned it, and then everybody knows that, and it doesn't get questioned because it seems like obvious, or it seems right, and it doesn't seem like it's conflicting with anything, and so you just roll with it. And there's been a lot of stuff, it comes up every once in a while. It's always lots of things, especially in genetics. Genetics started so quickly, in a way, once the discoveries took place, that a ton of assumptions on how things worked have all been overturned. But if you went to school and you were taught this is a fundamental building block, and not as our current best guess, physics is really good about, here's our current best guess.
But it's okay.
A lot of biology.
The physics.
A lot of
I know the biology, but like the physics of it. I mean, Blair said flying through water.
Yes.
We've been looking at flocks of birds migrating years, and we've been discussing how they draft, why they do this, how do they, the murmurations. We've never said birds fly. I mean, they do have some interesting stereotyped flight but why what we look at for birds, why is that not the same for fish?
Great question. And in fact, I'm so glad you brought that up, because what they found was that when they're swimming, the fish have a jet that goes backwards, which is similar to a jet engine of an airplane. So it's very similar to kind of drag when you're flying. And so it's beneficial to avoid being directly behind one another, kind of exactly what you're talking about, like how birds do a nice V formation. And so the latter formation provides hydrodynamic benefits. But the fish don't have to work as hard to synchronize because they can stagger on multiple planes instead of one. So this is the part that I have to tell you, though.
Please.
This computer simulation and the computer research was done by a robotics lab. So, of course, why were they doing this? They want to develop some underwater robot swarms that could move in dynamic ladder formations and gain energetic benefits.
Yeah, because it's biomimicry. We're trying to...
Underwater robot swarms. Sounds great to me. Just kidding.
Underwater. I mean, you could look at race cars. You could look at airplanes. That's all. Fast. So... robotics lab, did they ever actually have fish?
Yes.
Okay, so it's not just simulation.
No.
Okay.
Yeah.
But how big were their schools of fish?
They appeared to be pretty small.
Which I think is a confounding factor.
Yeah. No, I agree. So now that they have this model, they need to take these cameras into the ocean and record actual schools of fish. But I think it's so funny that kind of this conventional wisdom, the school of fish in Finding Nemo, all these things that we see where they make a nice diamond, maybe not. Maybe somebody just kind of made that up.
Did we see that in Finding Nemo? I remember they were in that the underwater river, right? The jet stream, or that's not the jet stream, the Gulf Stream underwater. And they were just like, they were. It was like a freeway. It was like Fifth Element.
Yes.
With all the
so it's interesting. I recall this because I haven't seen this movie in many years, but it's after that. It's towards the end of the movie. It's when Marlin and Dory get in a fight. And they separate, and then Dory forgets who she is. There is a school of fish, of these kind of like gray fish that pass her by, and then they stop and they talk to Marlin for a second, and then everybody gets scooped up in a fishnet. And then Marlin and Dory see each other, and they have to like fight their way out of the fishnet. And it's a whole thing. But I do believe that they move around in a school formation that is diamond-like.
I wonder if this is probably militarized. I'm assuming this is a way to get
No.
underwater
It's just,
drones
it's just to be able to
be
swim the
energy
fishes.
efficient and travel a long way underwater. So there's probably like a militarized aspect of this. But
Nah.
It's so you can swim in military formation to get into the sewers of Alcatraz so that you can infiltrate your way in. You can battle the Marine that's gone rogue, that has a bioweapon, and then you can use your friend Sean Connery, who escaped from the Rock previously, to find your way. No?
As long as we're on the tangent, do you know what my favorite part of that movie is? Do you know what my favorite part of that whole movie is? Is that was just the standard Hollywood movie where Nicolas Cage's character was supposed to say all kinds of tough-sounding curse words throughout it.
Yes.
And he apparently had, I don't know, a kid who was old enough to see one of his movies for the first time. And so rewrote the script to his part of it so that he took out all of the cursing. So he's like, oh, fudge no. Oh, gosh darn it. Like, but it was like the TV-friendly version, but he wrote it himself.
Yeah, I do believe that was Michael Bay's directorial debut. We're talking about The Rock, Kiki, one of my favorite movies of all time.
And
I've seen The Rock.
And it's kind of like my favorite thing about the movie once you realize, like, he's going to do the TV edit version of cursing throughout the whole thing. That to me is like the most entertaining part of the movie.
At least it's not like the radio edit of rap songs.
Hey, do you want to talk about while we're talking about, forbidden things, you talk about getting high. In elevation, that is.
Ba-dunk.
Animals living at elevations of 1,000 meters and higher have been shown to have a reduction in the genes related to smell and a smaller olfactory bulb than similar low-altitude species. Researchers looked at genomes of 27 different species of animals. They're all mammals living in high-altitude environments, and then they looked at their low-altitude relatives. They looked at monkeys, goats, llamas, guinea pigs, and many others. So they looked across lots of different types of mammals. They looked at domesticated and wild mammals as well. So they tried to cover all of their bases. They found a 23% reduction in the genes related to smell and an average of 18% size reduction of the olfactory bulb. And all of these changes appear to be specific to smell that they measured. No changes are found in genes related to pheromone or taste. So it really was just the reception of smells. And there could be a few reasons for that. There are environmental differences at high altitudes. They have thinner, drier, and colder air, which leads to difficulty in breathing. That can also cause increased nasal congestion and hypoxia, which is low levels of oxygen. All these conditions also make it harder for a scent molecule to travel. So there's just less scents in the air for them to detect. So if it's hard to smell things, why put energy into smelling it? The exact mechanism they're still unsure about. Reduced sense of smell could be related to the reduction of available sense. Just, yeah, like I said, if there's not sense around, why put energy into it? It could also have to do with nasal inflammation. It could have to do with that inflammation, meaning that they can't smell anyway, and therefore they don't put energy into developing a sense of smell that can't be used.
So my guess, can I
Yes.
throw in? I would be curious to compare the high elevation to an Arctic animal to see if it has to do with reduced population of things to smell that are of interest. Meaning they may not have a reduced sense of smell, but they may just be having a reduced population of smells that are important. And so I'd be really curious to see if like an Arctic fox, an Arctic hare, a polar bear has this sort of differentiation from, a more of a forest version of it, where there's going to be more, because you still need your sense of smell to, if you're an animal, to track prey over a distance and that sort of thing. So you'd still want to be able to smell your prey or your predator, right? But because there's such a dramatically lower population of animals at higher elevation or in the Arctic, maybe there's only a small set that are going to be important, and that's how it got narrowed down. So now I got to see if the Arctic versions that are not at altitude share this, because that could, if they do share that, it could knock out all of the elevation as the driver parts of the scenario.
I think it's much simpler than that. It could
also be like, I don't know, I'm sorry, when in desert scenarios might also then share this too, versus a forested version where you have to track multitudes of cohabitants.
So Justin, you're talking about habitat differences, which are very different from elevation differences. And in this case, a lot of these animals that they tested, the habitats were essentially the same. The difference was the elevation.
Okay,
right.
Well, then
so if I'm a guinea pig who's hanging out and it's a cold desert and I'm at 2,000 feet, and I'm a guinea pig and it's a cold desert and I'm at 10,000 feet, the habitat and the plant availability is essentially the same. Okay. What is different is the altitude. Yeah. And so it could be much simpler than that. Remember that animals are also shrinking at higher altitudes. There is generally less oxygen. It is generally harder to survive. You generally have less energy to expend on growth. So there were probably animals that had a worse sense of sight. There were animals that had worse hearing. There were animals that had worse senses of smell. And which ones survived? And it was the ones who lost the thing that was least important to survival. It really could be that simple. The other piece is that if you have less oxygen, you might want to get things to your lungs as quickly as possible, which will reduce the amount of nasal turbinates you have and pockets in your nose for air to get captured. You want everything to go straight in there as quickly as possible. Doesn't matter if you're losing moisture. It doesn't matter if you're losing temperature. You just want the oxygen in there as fast as it can go.
But then you'd also be losing heating ability, which you might need at elevation.
Right. So that's what I said. You're losing temperature, right? Yeah. So
there are adaptations for that, though. And like birds they have these really interesting respiratory and blood flow cross-current exchange systems that are involved so that you don't actually lose all that heat. And the turbinates with all of that surface area are actually like it's part of the way that it's conserved. But,
right. And so they didn't look at the size of the turbinates in this case. I will also mention this is specifically looking at genes and the olfactory bulb. So this is less looking at the mechanics of how they collect smell and more looking at how their brain interprets the smell they receive. And they are just not putting the effort or the brain power into interpreting the smells. The smells are still hitting their body and their nose, but they are not processing that information in the same way that their counterparts at lower altitudes are. The other thing I'll throw in there is they did also look at humans.
Oh,
They
cool.
looked at human communities at high and low altitudes. So happy they did that. They looked specifically at Tibetans, who are estimated to have established their mountain-dwelling communities at altitudes above 3,000 meters, sometime between 9,000 and 30,000 years ago. So in terms of human history, a long time ago. In terms of mammalian evolution, the blink of an eye. And so they compared that with the genomes of the low-altitude Han Chinese populations, and there were no changes in the human populations. Of course, because like I said, that was the blink of an eye. This could be due to also, they say, the mixed of lowland and highland populations, because humans are much more mobile and much more able to, for lack of a better word, kind of cross-pollinate across these communities. And so there may not have been enough generations of pure, like, separation of these two communities. So that's all very fair. The reason I think this study is especially interesting is because of climate change. And because, as a reminder, the reason I thought the elevation story with animals shrinking also is of interest is because as temperatures increase, animals will chase the habitat that they are used to and the temperatures that they are used to. And if I'm a snake in California and I want to go to where it's colder, I can move north. But if I am a guinea pig, I'll say again, and I am already 2,000 feet up the mountain, I can't move north. What I can do is I can move higher up in elevation. And there's two problems with that. One is there's less runway. If I am a snake and I'm in California, I'm in SoCal, let's say, I can go all the way to Alaska chasing my temperatures. But if I am a guinea pig on a mountain, I can go just a fraction of that distance because I can only go as tall as the mountain is high. As you go up that mountain, also reduced surface area, reduced room, more competition, and of course, reduced oxygen. And so as they do that, it's helpful for us to know, as conservationists, it's helpful to know what kind of changes you can anticipate to that community so you can help head that off as well while they are facing other challenges like relocation, like changes of their niche, like changes of their habitat and the food that they get and the predators that they have to worry about. If you also know that their scent is getting reduced, their body size is going down, then you can try to help conserve those animals in other ways as well. So yeah.
I love it. You got to know how the nose works.
Mm-hmm. The nose knows.
Nose. And it's fascinating that there's this convergent evolution that's happening where things are coming together.
Mm-hmm.
Yeah. Lost genes, but they're not lost, they're found. Oh boy. Justin.
Uh-oh.
Do you feel like you're ready to follow the animal corner in a more rapid way than, like, we got to get through things? Blair we're looking at the
We
clock.
got a half hour before her cutoff time. I can slow it down. You're right.
Start late.
Neurons have been duped. Neurons have been duped into delivering mitochondria to cancer cells, and they've been getting scammed this way for years. In fact, this is perhaps what's been fueling metastasis, the spread of cancers. So this is a thing. This is out of University of South Alabama. It's something that's sort of been noticed in pathology for a long time. You find the cancer cells that are doing a lot of growth, doing a lot of expansion, sort of embedded in tissues that have high concentration of nerve tissues as well. So this correlation has been seen for a long time but they don't really know why. And the other thing is, once metastasis gets into, cancer gets into certain nerve centers in the body, the spread becomes sort of exponential. It just sort of goes everywhere from there. So what's going on? Well, it turns out it's this thing called mitochondrial transfer, which is a normal process, a healthy process. It's actually one of the things that the cells use to try to fight off those senescent cells, those aged cells that have stopped working properly. Is that you'll have, and it happens in neurons too, when neurons become senescent. They're very important. So the astrocytes, which is not neuronal tissue, that is, there is a sort of support tissues around neurons. They'll be like, hey, I can see you're having problems. Here, take one of my mitochondria, and now you'll be a healthy cell again. A little sacrificing for the greater good. Astrocytes, glial cells.
It's like horizontal gene transfer, except an organ.
It's like, here's a better battery. Your battery's going bad. Here you go.
Amazing.
Take this one.
It looks like you were trying to run a functioning cell. Can I help?
Huh?
Like
Love
Clippy?
it.
So they did some really smart tagging, and they were able to track mitochondria and nerve cells as they transferred over to cancer cells. And it's sort of interesting because it is microtubulars or whatever are going out from the neuronal cells to the cancer cells to deliver the mitochondria. So in a way, it looks like, the neuronal cells have sensed that there is another tissue cell that is in trouble, and so it's trying to initiate rescue. Kind of the problem with that is neural cells are kind of the most important cells. They're usually not cells that are going to be doing a whole lot of the donating. They're usually getting donated to because they're so important that you need to keep them going, so they don't go around doing a lot of this sort of freelance rescue work. Those other cells are supposed to be in charge of that. And so what they discovered too is that it seems that there's something in the cancer cells, a signaling that was not defined, that was not quite discovered, but they could tell that it was raising the amount of the signaling networks that would be required for the neuronal cells to do delivery. So basically, they were initiating the transfers by stimulating the neuronal cells to do these donations. Anyhow, this is kind of a big deal because we didn't really know how this was happening. And so this is a new avenue that opens a door to a pathway to crawl through a window of targeting nerve availability to tumor sites.
So many nice words.
One of the things that we have looked at quite a bit is vascular access. The ability for nerve cells to access nutrients by coopting vascular networks and that sort of thing. And that didn't really seem, when they were testing this, it doesn't seem like that was a big influence on growth and metastasis and travel. What was whether or not there was neuronal tissue there, whether or not there was nerve tissue that could donate mitochondria. That turned out to be the powerhouse. So a lot of tumor suppression is about reduced vasculature. It's about reducing the amount of blood flow nutrients to the tumor. And so this is like, hey, great idea, but it may actually be access to nerve tissue that is the more important factor that needs to be targeted and concentrated on. So this could be one of those. It's just a study in mice now, but it could be something that really is kind of a big change in approach to tumor suppression. Now that they realize that this is a sort of mechanism that is that is driving metastasis. Okay.
I had, I think, I don't know if it was this particular paper this weekend, but just dug deep down in the rabbit hole of the interactions between the, yeah, no, it's a different, we started talking about like prions and other things, and it dug deep out down into the glial cells and nerve cells and the interactions between them. And there are two groups of glial cells that are within the brain. Astrocytes are actually from the same tissue that neurons come from, and astrocytes can make new neurons, not just give them mitochondria. So this is a really cool part of it. And these in glioblastomas, which is, you know, a terribly deadly type of cancer that we have a hard time treating because of the blood-brain barrier and getting things into the brain. And they've discovered that glioblastomas have this kind of relationship in the communication between the cancer cells, the tumor cells, and the glial cells, astrocytes, but also is it the astrocytes? It's anyway, there are immune cells that are related, that get released by the lymphatic system, that are the capillaries and the blood supply around the brain that release immune cells into the brain. And this is a new thing, really understanding that the immune system actually works in the brain, and the glial cells are a part of this entire immune process. And the reason that you have some glioblastomas that you can treat and that never come back, and others that come back again and again and again, it has to do with the way that they communicate with the instructions for growing vasculature, and surrounding themselves to fight off macrophages. And they use them. They expose major histocompatibility complexes that say, "I'm okay, don't kill me," so that, you know, the immune cells don't come and eat them up. And there's this real push-pull between the glial cells that come from the immune system. So there are macrophages that become glial cells. They're like, so it's the whole story. This last weekend,
Wow.
rabbit hole, had
Wow.
such a great time. Our brain does have an immune system, and glioblastoma potentially has treatment pathways related to the immune system and the way that the cells that are the glial cells within the brain, there are ways that we could potentially change the communication relationships between the tumorous cells and the immune cells in the brain. I have to find the study because it was.
Yeah, you should bring that study. I want to hear all about it.
Oh yeah,
Sounds like it's incredibly fascinating stuff in there.
yeah. It wasn't just this. This study was it, but it wasn't this. It was something else. Something else I read. There was another one. I don't know. Tell me another story. Do you have another one? This is cool.
Neuroscientists.
I like more brains. Yeah.
Neuroscientists remain steadfastly uncertain about how the brain encodes memory.
Yep.
Oh gosh. So this is kind of fun. So there's we've been looking at the brain for 100 years or whatever. And there's a lot of ideas of how memories are stored. Is it structure? Is it active brain waves in different parts of the brain working in concert? There's all sorts of different. Is it some sort of atomic level, or
Yes, and
so they survey, or is it all of it? Is it a combination? Anyway, they tried to survey something like 300 neuroscientists, but they got they actually sent it. It doesn't say here. Where is it? Email invitations reached 305 engram experts. I think those are the ones that have like this concert of memory storage and structure and and signal. They got 33 of them to respond. And they had a bunch of other people who are in neuroscience, but maybe not experts in stored memory. So they ended up with a cohort of about 312 neuroscientists from these different groups, different levels of experience, and different years, and different levels of education, experience, and that sort of thing. And they just gave them a survey. They gave them a survey. And this survey is kind of weighted. I think whoever did this survey is interested in the concept of memory retrieval of a preserved brain. So they asked a lot of questions about that. But those questions are kind of revealing in where researchers think the brain is going to be storing and how it's going to be storing that information. What they found was there's almost no consensus on anything. Very, very little consensus among neuroscientists. Let's see. They say, could detailed maps of neuronal structure alone contain specific memories, such as a learned route through a maze or a memorized password? Around 46% of the respondents agreed that this was theoretically possible, provided sufficient sophisticated methods existed, meaning that they do believe that memories are structurally locked into a brain. Okay. A third of the respondents strongly disagreed that this was possible, meaning they don't think memory is structurally bound.
We have no idea.
Let's see. Respondents identified additional information potentially necessary for memory readout, most frequently citing dynamically changing neuronal activity patterns, 47%, contextual data on experiences and mental states, 43%, sensory motor information, 37%. Less frequently selected were chemical and electrical gradients, and quantum level properties only reached 5%. So, and the reason this is sort of interesting is that there's so when people say, okay, it is connectivity, it is these connections across the brain, these synaptic connections across the brain working together that create a definitive memory trace and create that, resurrect that memory. But there's things like, I guess, hypothermia, where these fine structures where that idea is based on sort of break down, or certain stresses or certain conditions where somebody can go into a coma or have, limited brain activity for a long period of time and then be resuscitated back to normal, and they still have their memories. So it can't be being kept alive just by repeated synaptic activity. That feels like it's got a hard encoding somewhere, right? And then, anyway, basically, the consensus so far is that they don't know. And they're waiting for better observational things. And so this isn't a bad thing, though. It's not a bad thing that a bunch of scientists who are experts in a field all disagree, or largely disagree, and can't form a consensus on something that hasn't been completely understood. If they did have a consensus and we still had no mechanism for memory storage, terrible thing. That means everybody's working on the assumption that they'll figure out it's the thing they already think it is. This way, with all of this lack of consensus and a lack of mechanism, you have people looking in different directions. You have people testing different hypotheses. You have people trying to break down the problem in different ways that might mean completely different. The brain stores memory a completely different way than 30% think it does, or 40%, or even 70% think it does, because at this moment, the field is free to explore, because nobody can give them the definitive answer. even though they all have their probably whatever they learned from their professor, who's their mentor back in school, is how they think the brain stores memories, and it's just time to get it proved. But they're different professors with different ideas teaching their students, who then go forward thinking it differently, is how these different branches of exploration sort of come about. So the news from there so far, we don't know. And my last story for the night.
I'm just gonna jump in here for one moment, and I agree with everything that you're saying.
Oh, good.
Yeah, because I think that it is a large field, and people study these really niche topics, and they maybe don't know about these. So I would like to know exactly what was the makeup of the particular, like, the emphasis of the neuroscientists that they talked to.
So
Like
can
the
I tell
way
you?
that
Yeah.
the way that it all came out, and I mean, I'm looking at the results of this and going, no, 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 no.
Right.
I'm like, nobody knows, so why are you saying that you do know? Like, the results on this are driving me crazy.
So can I tell you something else that will drive you nuts?
Yes, and go ahead.
Let's see. Okay. Neither research background, experimental versus computational expertise level significantly influenced the respondents' perspectives. So being more educated or more
So
of
they
an
controlled,
expert
they controlled
didn't
for it.
push you in one direction or another.
Mm.
That's how bad the consensus is. And when I say bad the consensus is,
It's how little they agree.
how little that they agree. And which is, again, in a field that we don't have the answers to, that's exactly what you want, is people pursuing different narrow paths towards a potential truth. Yeah. You don't want everybody agreeing, this is the thing, this is how it works, we can't prove it. These aren't psychologists, these are neuroscientists. They're not gonna assume a knowledge that's not actually in hand. So, but they kind of have to. You kind of have to pick a lane and go study that lane and see if it turns out to be true, and try to isolate and try to create the next better experiment to see if this version is true. It's just also part of the problem, I think, in this field is going to be that they're all going to be a little bit right. That all of these aspects of synaptic activity and structure are going to be non-isolationally correct, meaning they're going to rely on the other at times. They're going to be complementary and at times in conflict, but there's going to be a hierarchy, but that hierarchy probably loops back around on itself. It's probably so integrated that they're all going to have. It's like the elephant in the dark, that scenario. Like, yeah. Oh, what is this thing in the dark? Oh, it's big like a wall. No, it's round and tall like a tree. Or they feel the tail and it's like, oh, it's like a small snake.
Elephant tail.
Everybody's got a different piece of the elephant, and they are thinking the elephant.
It's a broom. The trunk is a snake.
Is a very different thing than all the others are describing. But it turns out when you add it up, they're all describing an elephant, and it all makes sense. Last story of the night. I think we touched on it in the disclaimer, but thankfully, PBS, Public Broadcasting System, is still giving out news. Basically, they're reporting on the fact that the websites of the government agencies are removing all mention of global warming and climate change. They reached out to NASA, and they got no reply. They reached out to NOAA. They got no reply. The government organizations that we've been relying on to give us information about the changing climate have been told not to share that information with us. And they're, in fact, at this point, not even talking to the press about the rationale behind not sharing that with us, because the government is working in a way that it was never intended to at the moment. And that's kind of all that story is. It doesn't mean that global warming or climate change or climate is stopped. It just means your government can't talk about it anymore. With all implications of what that means for society.
Additionally, many researchers who are still within government agencies have been told that they cannot read certain top journals anymore because the subscriptions to Elsevier, Nature, Science, many major journals has not been renewed by our government. So the scientists...
This is
Right,
censorship.
Yep.
It's censorship of science.
Yep.
Not of an opinion. It's not even censorship of opinion. It's censorship of fact. It's censorship of research. It's censorship of peer-reviewed scientific work. It's beyond just frightening. It's also...
It is active destruction.
Yeah.
It is
So people are meant to report on the weather. They are meant to...
But you can't anymore.
Right.
No, they've been shutting that down.
At least not accurately.
There's a whole thing in Florida where some of their most famous people who guide you through the hurricane when you turn on your TV news down there, basically came out and pleaded with everyone in his listening audience to call their representative. He's like, I can't tell you next time there's a hurricane. I can't tell you the sea level rise. I can't tell you what parts of what time to be aware, what direction to head. I can't give you all of that piece by piece information that I've used in the past to cover all of the hurricanes that we've been through. It's going black if you don't call your representatives and get them to stop this. So we'll see. Hopefully.
Well, my point is, while this is going on, it's on people who are not sitting in government jobs to speak about climate change often, because they're the ones who can.
Yeah.
All these people in federal positions that are being told they can't talk about things publicly, we have to hold their weight until they're allowed again.
Yeah.
And that stinks. Yeah. But it's where we are.
What was that movie? Don't Look Up? It is absolutely Don't Look Up. In reality.
Idiocracy hasn't been funny for a long time.
Idiocracy doesn't even touch this. This is much more Don't Look Up.
I couldn't actually finish Don't Look Up. It was too much. I was like, I can't take. It was great.
Well, I think it has a happy end. Oh wait, no.
No, it doesn't. No. Spoilers.
Does it? Or does it? Or maybe it does.
The post-credit scene is decent.
That's kind of a happy ending. Okay.
That's good. And, we had celebrities learning about and talking about the science and everything. And the story really these days is, how can we really get across to people how important science is for daily life? What good does it do? What good does your money going to government funding of science do? Why not have private interests? Dow Chemical, what harm have they done?
Oh gosh.
I didn't say that. It was generally like
disclaimer. Everything we say, we just made up on the spot. Never mind.
Just misspeaking there
just
for
kidding.
a minute. Yeah. But we're getting at the end of the show here. So moving past, what's happening in the United States congressionally, in our administration, and what is potentially being passed, not passed, regulated, deregulated, funded, not funded. It is important for people who understand science, who believe in the good of science, to not just think that other people are going to get it too, because that's what you think. So it's why it's the why is it cool that triglycerides are an important fuel reserve for nerves in the brain? What? So people talk about all the time, like, the brain, oh my gosh, just thinking uses so many calories. Like your brain is like this energy burning organ, machine, processor, whatever. Most people have thought and have shown through research that sugar is the main source of energy in the brain, that the brain is constantly like using sugar. Glucose, love it. Glucose is going to get me through the night. And, you eat candy bar, you have your little power bar, you have your little, what M&Ms, Snickers bar. I'm going to get it through sugar. Yeah, we can do it. People haven't really talked about the fat in the brain. The fat in the brain is usually thought of as the, it's like, it's there, but it's not something, they don't find fat globules within the cells, the nerves in the brain. You can go throughout the body and you find fat cells, you find lipid globules, there's fatty acids all over the place. And there is fat, which is stored energy that is easily accessible by, with these storage abilities throughout the body. The brain, we haven't really seen that before. So everybody's been kind of like, nah, the brain doesn't use fat. The brain, whatever. New study has discovered, hey, back to glia, that that there are glia that come over just like the mitochondrial kind of thing, that the glia show up and they help to deliver lipids, that there are neurons, they have fluctuating fatty acids that get derived from these lipids, and but then the neurons use it, that when the fatty acids, the lipids get delivered to the brain, the neurons immediately take it and they give it to the mitochondria to give the mitochondria energy to do the work. And it's not always sugar, but they don't store it. It's delivered. And it's the astrocytes, it's the glial cells that are talking to the neurons. And the like you said, the astrocytes are delivering the mitochondria. Oh, you're tired. Oh, you're running down. Your mitochondria are running. Here, have a mitochondria. They're also saying, let me bring you butter. let me bring you this wonderfully energy-filled store of fatty acids.
Neuronal waiter and concierge.
Yeah. So I thought that was
support.
Yeah. And it also kind of, it's this new understanding of how these glial cells and the neurons work that can also be used in our understanding of the metabolism of neurons, the mitochondria, and how the brain functions. So why do neurons get tired? What breaks down first? Is it the mitochondria? Is it the delivery of these fatty acids and lipids? Like how does that system all work? So the researchers, and for the first time, they're like, hey, nah, these neurons, actually, they eat fat. They like it and they need it. So there's stuff involved in that, and it's very cool. Fatty brains, that's good. You should have a fat brain, or you should have a brain that likes fat. And my last study is a birdie study, because birds are so wonderful. You like chickadees? I love chickadees. Chickadees are chickadee-dee-dee-dee.
I don't even know if I really know what a chickadee is.
What?
To be honest.
What?
I don't know if I've seen one. Maybe I've seen thousands. I'm assuming it's some kind of small bird, but if you took 50 different small birds, or even 3, I had probably poor odds of figuring out which one's the chickadee.
Okay, well, let's see. I'm not typing right. Blair left, so
Figure out which one of
did
these
you leave
birds is a
already?
chickadee.
We will ask you a really quick question. It just came out. Anyway, this PRA. I used to work with the lead researcher who was the head of the lab in which this research is done. And Vladimir is also an amazing photographer and takes pictures of chickadees all the time at his field sites. And they're just wonderful images. And these cute little birdies, there are so many of them. Oh, I got to share the page so that you can share this tab. So there are black-capped chickadees, there are mountain chickadees, there are chestnut-backed chickadees. They are parids, so they're related to the European birds, the great tit, the blue tit, the parids. So family Paridae. And these birds are really small. They have incredible memories because what they do, they've adapted for food storing. And so during the summer, their brains kind of shrink their hippocampus, their brain kind of shrinks up a little bit because they're going to be running around and just doing sexy things, trying to just get around their environment and, have mates, make babies, do all this stuff. But then their brain goes, ooh, I got to grow because I have to remember where I put my keys. And so their brain grows, they start putting food all over the place. And every day they store food, and it helps them to survive through winter conditions. And these birds very often are in mountainous regions. They also have a spread up to the north, up through Canada and toward Alaska and these northern regions. And they exist in very, very cold situations. One of the very, very early studies on the memories of chickadees was on the Siberian, not chickadees, but tits, the Siberian tit, which is a Siberian bird. And it has the claim is of the memory is stores some 250,000 items over the winter, the winter season.
It's got me beat by like a lot.
Yeah. So these birds are amazing, and they have a variation along the ecosystem, like the environments that they live in. And so this study looked at the evolution of spatial cognition in the food caching chickadees. So what they did is they looked at multiple populations around these environmental gradients to see kind of the causes and consequences in individual variation, not just, population level variation, but like, oh, you're the one that doesn't remember where you put your food versus the good rememberers who, survive really well. So they also looked at the genetic basis of that variation. And they showed that chickadees, and this is from the abstract, chickadees in harsher environments have better spatial cognitive abilities and a larger hippocampus with more hippocampal neurons, with differences between populations persisting in common garden experiments. So they could take, it's like, oh, harsh birds, but I got bird feeders. We could do a little garden test and tell the difference between the abilities of these different birds. Chickadees tested in the wild had extensive individual variation. So not all chickadees remember the same, just like, people. And the variation is heritable and has a genetic basis. And it's associated with significant differences in survival, lifespan, and reproductive success, as you would guess. But there's also luck. So what their study is really showing is that chickadees and the evolution of their memory and their abilities is really shaped by the environmental conditions and natural selection. If you have more of the good members, then you're going to have more babies
Maybe.
that survive. It's all
But
it's
wasn't
all
it
of it.
scrub jays, the
Scrub
bluebirds
jays.
that we discovered that, you know, they're pretty smart birds.
They're
Don't
very
wanna
smart birds.
take anything away from them.
I love
But
my scrub jays.
their ability to remember where they buried things was thought to be really high because they bury things, in the summer and then go find them in the winter or what have you. And then it turns out, no, they just bury stuff everywhere, as do a bunch of other scrub jays. And then they go look everywhere and they find their stuff or maybe another scrub jay stuff or maybe some squirrel stash. They're just looking everywhere. And that's what it turned out to be. That it was
kind of it's kind of both. Yes, they put
Yeah.
it all over the place and they probably don't remember where every single thing is, but there's been study after study that has shown that like these scrub jays and other jay species and corvids, hummingbirds even also, are able to remember the what, where, when of in at least a test situation. And scrub jays are also like they're aware of other birds watching them. So they're going to do fake caches. They're going to be like, oh yeah, no, I put it here. And then there's a whole dynamic,
perfect.
interaction going on between different organisms there. But the hippocampus, we have a hippocampus. It is involved in our memories. It's involved in our ability to remember things. It's part of that pathway. It's like the librarian that has the Dewey Decimal System or whatever, that as the information comes in, it goes, you are going to be filed here in a distributed manner that nobody will ever understand. But the hippocampus is essential for long-term memory and recollection. Yeah. The bigger your hippocampus, I don't know, maybe the more you remember. I don't know. But are we ready? Have we done it?
That's if the brain is purely structural. See, like it's like.
But there's that is a structural part. I'm not discounting the rhythms of the brain that are related to the electrical signals that happen throughout the day, throughout how the networks, how they stay connected. I'm not discounting little actions that take place electrochemically at like the synapses. I'm not discounting the glial cells that are also part of sending and controlling how neurons respond to things in different moments. And I am not discounting either the potential magnetic, like electromagnetic forces because of the electrical signals that are be carrying down and the interactions between those and individual tiny neurons and the other ones around them. There is so much. And sure, quantum might be there. We found quantum in pigeon eyes, like quantum detection for navigation in pigeons. I'm going to say yes, and there's so much we don't know. We know little teeny tiny pieces of it, and there's this little piece and that piece and this NMDA receptors, AMPA receptors. Oh, the glutamate receptors, all the things. Glia, neurons, dendritic cells, macrophages. There's so much. We know nothing. We know nothing. We have so many questions. At least I do. You ready?
Did we do it? Was that another episode of This Week in Science, episode 1021? My goodness. That went so quick.
It did go so quickly. It did. And I'm shutting all these tabs right now related to all of our stories, closing it down for the night as I
would
get
just like
ready
to say
to say,
to everyone out there,
yeah,
thank you for listening.
that was it.
We really hope you enjoyed the show.
Mm-hmm.
If you didn't, keep it to yourself. But if you did, let us know.
Yeah, and let somebody else know and have them listen to the show too. Why don't you bring a friend next time? Be
Yeah.
great. We'd love to see you. I have so many people to thank. Thank you, everybody who was in the chat room tonight. All of your comments were fantastic and very, very appreciated. Additionally, people who help with the show on a regular basis. Fada, thank you for helping with show notes and the social media. And Gord and Aaron Lauren, others, thank you for helping to make sure actually everybody, thank you for helping to make sure the conversation
All the things
in the chat room is always a good one, right? It's there and it's ours.
I have, by the way, if you've ever dipped into another chat room,
it's not like
not
this.
the same.
Nope.
We have the best chat room. The side chat conversation is better here than in any other show that I've ever scooped in on.
Yeah. Maybe don't tell anybody about TWIS then, because we want to keep it like this to ourselves. I'm kidding. Please. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. And of course, thank you very much to our Patreon sponsors. Ooh, I'm starting at the bottom of the list. Maybe I'll read from upside down tonight. Thank you to Tony Steele, Patrick Pecoraro, Paul D. Disney, Marjorie, Bob Calder, Kevin Parachan, Adam Mishkan, E.O. Lawn Makes, Eric Knapp, Dave Neighbor, Jason Old, Sue Doster, Craig Last, Landon, Kurt Larson, Philip Shane, Paul, Rodney Lewis, Dave Wilkinson, Rudy Garcia, John Atwood, Greg Briggs, RDM, Christopher Dreyer, Flying Out, G. Burton Lattimore, Remy Day, Johnny Gridley, Brendan Minish, Richard Christopher Rappin, Howard Tan, Ken Hayes, Steve Leisman, aka Zima, Mark Hessenflow, Greg Riley, John McKee, Sean Clarence Lamb, John, David E. Youngblood, Brian Carrington, Jack Noodles, Kevin Reardon, Paul Ronovich, Fred S104, Andrew Swanson, Daryl Myshak, Stephen Albaran, PIG, Don Mundis, Shubru, Ellie Coffin, Jonathan Stiles, Vegard Shefstad, Chris Wozniak, John Ratnaswamy, Pierre Velazar, George Corris, Kent Northcote, Bob Coles, Richard Badge, Teresa Smith, Marie Gitz, Craig Potts, Arthur Kepler, Aaron Anathema, Alan Viola, Eden Mundell, Dana Lewis, Lauren Gifford, Robert W. Farley, and Robert Norland. It was harder to read.
That was amazing. I don't think you were going to be able to do it because like some of it must be like muscle memory at this point.
But I was used to going one way and I was like, oh, I'm going to do the other. Yeah, that was pretty fun. Thank you, all of you, for supporting TWIS on Patreon. And if any of you are out there and feel like you'd like to help out an independent science podcast who is trying to be unbiased and just, share and be curious with you and, have conversations that are respectful and whatever, we'd love your support. So please head over to twist.org and click on the Patreon link because you are how we are supported. On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, broadcasting live from the Twitch, YouTube, and Facebook channels.
And if you want to listen to us as a podcast, which we are, you can just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get on their phone or their whatever device and subscribe them to the show as well, too.
Yes, for more information on anything you've heard here today, links to the stories will be available on the website, www.twist.org, where you can also sign up for a secret newsletter.
And I'm thinking more and more about writing things. More and more. I think about it all the time.
Thankfully, we're all tragically, fully committed to procrastination. So if you sign up, you might still never get a newsletter. It's just possible that the amount of time it will take for us to put out a newsletter might outlast the show or us.
But isn't it the joy of not knowing? You
The
What's at the bottom?
excitement of will they or won't they ever actually send me a
What is
newsletter?
What's at the bottom of the Cracker Jack box? We'd love your feedback. If there is a topic you'd like us to cover or address, or a suggestion for an interview, please let us know, maybe on a social media account, or send us an email. Just put TWIS in the subject line so your email doesn't get spam filtered into I don't know.
It's so hard. I don't know how Blair does it.
The confusion of neuroscientists, like that all of it, they wouldn't even. I don't know. What is this email? I don't know. Put TWIS in the subject line.
We look forward to discussing science with you again next week. If you've learned anything from the show, remember,
it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's this week in science. This week in science. This week in science. 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 This week in 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 science. This week in